current, electricity, electric current, conventional current, drift velocity of electrons and current, current density, Ohm's law, resistance, resistivity, conductance, conductivity, temperature, dependence of resistance, color codes for carbon resistors, series and parallel combination of resistors. On this concept, some of the assertion and MCQ questions are here. I request you to see the last and see the answers for all class 12th and 10th class, whomever wants to learn these concepts. And if content is good, like it and subscribe my channel. Thank you. And see the assertion questions here under.
Absolutely. Let's create some assertion, reason and MCQ questions based on the topics listed in your image related to current, electricity, I. Assertion, reason questions. Instructions. For each of the following questions, two statements are given. One is labeled assertion, A, and the other is labeled reason, R. Select the correct answer from the codes A, B, C and D given below. A. Both A and R are true, and R is the correct explanation of A of B. Both A and R are true, but R is not the correct explanation of A of C. A is true, but R is false. D. A is false, but R is true. 1. Assertion. A. The drift velocity of electrons in a metallic conductor is very small, yet it can carry a large current. Reason. R. The number density of free electrons in a metallic conductor is extremely large. 2. Assertion. A. Ohm's law is applicable to all conducting materials. Reason. R. Ohm's law states that the voltage across a conductor is directly proportional to the current flowing through it. 3. Assertion. A. The resistance of a semiconductor decreases with increase in temperature. Reason. R. Higher temperature leads to greater vibrations of the lattice, hindering the motion of charge carriers in a semiconductor. 4. Assertion. A. In a series combination of resistors, the current through each resistor is the same. Reason. R. A series circuit provides a single path for the current to flow. 5. Assertion. A. The EMF of a cell is always greater than its terminal voltage. Reason. R. There is always some internal resistance within the cell causing a voltage drop. Multiple choice questions. MCQ. 1. Which of the following is the correct expression for current density? J. AJ equals E by RO, where E is electric field and rho is resistivity. BJ equals rho by E. CJ equals sigma E, where sigma is conductivity. D. J equals E by sigma. 2. The color code for a carbon resistor is red, orange, gold. What is its resistance value? A. 22 times 10 to the 3 ohms, plus or minus 5%. B. 22 times 10 to the 4 ohms, plus or minus 5%. C. 33 times 10 to the 3 ohms, plus or minus 5%. D. 47 times 10 to the 2 ohms, plus or minus 10%. 3. Mobility of electrons is A. Drift velocity per unit electric field. B. Electric field per unit drift velocity. C. Product of drift velocity and electric field. D. None of these. 4. Two wires of the same material have lengths in the ratio 1:2 and radii in the ratio 2:1. The ratio of their resistances is A. 1:2, B. 2:1, C. 1:8, D. 8:1. 5. Conventional current is the flow of A. Electrons. B. Protons. C. Positive charges. D. Both electrons and positive charges. Answer keys. Assertion, reason questions. 1. A. 2. D. Ohm's law has limitations, not applicable to all materials. 3. C. Resistance of semiconductor decreases due to increased charge carriers. 4. A. 5. A. Multiple choice questions. 1. C. 2. A. 3. A. 4. C. 5. C. Explanation for some questions. Assertion, reason 3. Assertion. A is true. Semiconductors exhibit a decrease in resistance with increasing temperature. This is because higher temperatures provide more thermal energy to the electrons, freeing them to participate in conduction, thus increasing conductivity and reducing resistance. Reason R is false. While it's true that lattice vibrations increase with temperature, this primarily hinders the motion of charge carriers in metals, leading to increased resistance. In semiconductors, the dominant effect is the increase in the number of charge carriers. MCQ 4. Resistance. R is given by R equals rho LA, where rho is resistivity, L is length, and A is the cross-sectional area. Let the two wires have lengths L1 and L2 and radii R1 and R2 respectively. R1 by R2 equals rho LA, L1 per liter 2, down of Humpy, L1 by R1 down of Humpy, L1 per liter 2, down of Humpy, pi R1 to the power of 2 by R2 squared equals L1 per liter 2, down of Humpy, R2 squared by R1 squared. Given L1 per liter 2 equals 1 half and R1 fly R2 equals 2 over 1, so R2 by R1 equals 1 half.
R1 R2 lig med en halv. En halv cirkumflex 2 lig med en ottendedel.
Let me know if you'd like more questions or a deeper explanation of any of these topics.
Like it the channel, I will provide you more and more such a questions for revision for 12th class and 10th class. Thank you.